In this chapter, we're going to continue talking about organic function groups. And specifically, we're going to be talking about carboxylic acids, esters, amines, and amides. So for the first question, it states, draw the condensed structural formula for each of the following. So the first one is going to be hexoacetate. Hexo means that there's going to be 6. So we're going to start out with drawing our 6 carbons. So there's the hydrogen that's going to start it off. There's the first carbon. There's 2, 3, 4, 5, and now there's the 6th carbon. And coming off that carbon is going to be now our acetate group. As such. Next one is propylmethanoate. And so we can start with the propyl group. So there's the hydrogen, it's the carbon, and then we're going to go 2, 3, and then that's going to be bonded to an oxygen, which is going to be bonded to a carbon, and then the hydrogen. So here's the methanoate group right there. Next one is going to be propylbenzoate. So we can draw the benzoate group first. It doesn't matter which one you draw first. I sometimes flop around depending on which one's going to make it the easiest for me. So this is going to be our benzoate group right here. That's our benzoate group. Now we have to draw the propyl. Meth, eth, prop. So that means 3 carbons. And so that's going to be 1 carbon, 2 carbon, and then here's the 3rd carbon right there. Let me go back. This is going to be our acetate. This is going to be our methanoate. This is our propyl group. Back down here, this is going to be our benzoate group, and this is once again going to be our propyl group. All right. If you have any questions on this, please let me know. On this problem, it states, classify each of the following amines as either primary, secondary, or tertiary. An amine is going to be the nitrogen group. Now, it's going to depend upon the number of carbons that are bonded to the nitrogen. All right? And so for the very first one, we have 1 carbon bonded to the nitrogen, and this is a primary amine, which is written as 1-, or primary is what that amine is going to be. We come over here to the next one. We see that this nitrogen is bonded to 1, 2, 3 carbons, and so this amine is going to be a tertiary amine. We come down to this amine group right here. This nitrogen is bonded to only 1 carbon, and so this is going to be a primary amine. That's going to be a primary amine. This nitrogen, oops, I left the hydrogen off. There should be a hydrogen right here. Nitrogen is going to have 3 bonds. This nitrogen right here is bonded to 1, 2 carbons, so this is going to be a secondary amine, If you have any questions on problems similar to this, please let me know. In this problem, we want to determine whether the solubility of the amine in water. So we want to indicate whether the amine is going to be soluble in water or insoluble in water. Now the rules for solubility are such that if it contains 1 to 5 carbon chains, it's going to be a soluble amine. If it has 5 or more carbon chains, it's going to be insoluble. So the first one here, this carbon chain is 1, 2, 3. There's our amine, so this is going to be soluble. Over here, this contains 5 carbon chains, or 5 carbons. The chain is 1, 2, 3, 4, 5. So this is going to be slightly soluble. It's not going to be entirely soluble, but just ever so slightly soluble. This contains 3 carbon chains, and so this is going to be soluble. There's only 3 carbons in this amine, therefore it's going to be soluble. Now this amine, each one of these vertices is going to be a carbon, so there's 6 and 6 carbons here, And so there's 12 carbons in this molecule, so this would be insoluble. If you have any questions on the solubility of amines, please let me know. In this problem, we have a medicine up here which is Voltaren, and this is used to treat acute or chronic treatment of rheumatoid arthritis. I'm a physical chemist. I don't deal with molecules this big. They actually kind of scare me. Just kidding. But what we want to do is we want to identify the different functional groups in this molecule. And so an easy one we can see right here is we have an amine. We've been already talking about amines, so this is going to be an amine. All right. This is going to be an aromatic. So that's going to be an aromatic. Then we've got this one. Now, if we didn't have the sodium here and we just had a hydrogen here, that would be carboxylic acid. But what we have here is we actually have a salt. So this is a salt, meaning we have an anion and we have a cation. And so this entire entity is a carboxylic salt. Carboxylic salt, or sometimes referred to as the salt of a carboxylic acid. But this happens to be the anion, the carbonate. This happens to be the cation, so this is going to be a carboxylic salt. If you have any other questions pertaining to this chapter, please let me know.